In Geometry Section 6.2, we're dealing with parallelograms and properties of parallelograms. Basically, if you've done your vocabulary, you know that the definition of a parallelogram means the opposite sides are parallel. Now, there's a whole section, a whole chapter in your previous flipper that you should have that deals with parallel sides. That will help you be able to answer the proofs in this section. So make sure you have that handy in class. So, parallelograms, basically opposite sides are parallel. Once you have a parallelogram, a whole bunch of other properties come in. So it's a four-sided figure, and the first property is that, again, both sides are parallel. So AB is parallel to DC. And again, the term parallel means they have the same slope, so they never intersect. So, and also BC is parallel to AD. With that, I can also say that AB equals CD, so this equals this, and I can also say the other side. So opposite sides are not only parallel, but they're equal, and that's theorem 6.3. Theorem 6.4 tells me that opposite angles are equal. So angle A equals angle C, and angle D equals angle B. That's theorem 6.4. It also tells me that all angles are supplementary. So that means if I do angle A plus angle B, I get 180, supplementary. If I do angle B plus angle C, I get 180. If I do angle A plus angle D, I get again 180, and so on and so forth. And angle C plus angle D equals 180. So this is theorem 6.5. So this is example of 5. All angles added, not all together added, but any pair of angles are supplementary. Alright? Number 6, if one angle is 90 degrees, then all of the angles are 90 degrees. So basically, if I say A is 90, then B is 90, C is 90, and D is 90. And those are the properties for just the basics of a parallelogram, so make sure to pause it and write it down. But we also have properties when we have diagonals. And diagonals are the ones where you connect opposite sides. So when you connect opposite sides, this is a diagonal. So SU is a diagonal, and as well as RT. So they're both diagonals. Okay? And what it tells me is that when there is a diagonal, that Q is the bisector of all of them. So I end up with RQ equals QT, so this equals this, and then same thing, this equals this. It also tells me that these triangles that the diagonals make, so triangle RST and triangle, okay, TUR, they're equal. So it creates equal triangles through, there's various reasonings, so that's theorem 6.8. Now with all that information, you're going to use either to solve a proof, or you're going to find the information of the parallelogram, of what it's asking for. So in this one, for example, it wants us to find URT. So URT. It wants us to find this, okay? And it wants us to find RST, so it wants us to find this whole thing right here. And then it wants us to find Y. So here's Y. Well, we're going to start with Y because it's the easiest. Y is an opposite side. So the difference I know between a side and an angle is that the angles have little circles. That indicates that it's talking about an angle. This one is dealing with the side, and we know that in a parallelogram, opposite sides are not only parallel, but they're congruent. So I know that RS equals UT from one of the theorems. So I know that 3Y equals 18. Divide both sides by 3, I end up with Y equals 6. So we've got one of them. The next ones are going to be a little more tricky. If I want to find RST, I know that this whole angle is 58 degrees, right? Angle UTS. I do know that angle T plus angle S. One of the theorems says if I add any of the two angles in a parallelogram, I should get 180. Now, if I know that all of angle T is 58 degrees, 40 plus 18, plus angle S, I can easily solve for RST. RST is the same thing as angle S. Okay? So, equals 180. What do? I just subtract 58 from both sides. I end up with angle S equals, it's been a day, 122 degrees. And this is the same thing as angle RST. Alright? Now my last one uses, again, when I was talking about that chapter, I was talking about parallel lines and transversals. Well, we're dealing with these angles right here, and I have I have these parallel lines, and this is R, U, and ST. So I'm just going to draw what I need. So here are the sides, and I'm going to extend the sides, and I'm going to take this and make this into a transversal. And I know that this is parallel to this. Right? And I know that this is 40 degrees, and I know that this is 18 degrees. Well, if this is parallel, and this is a transversal, I know that this angle and this angle are equal because they're what? Alternate interior angles. Do you remember that? Alternate interior angles are in fact equal. So if this is 40 degrees, then angle URT is also 40 degrees. So angle URT is equal to 40 degrees because of alternate interior angles. So go ahead and write that down, and please refer to the properties when you're solving page 328, number 6, 8, and 10. Refer to the properties to help you figure out how to find the measurements. So page 328, number 6, 8, and 10, and I will see you in class.